In this video, we are going to look at the fascinating world of dimensional analysis by diving into a common problem encountered in physics and engineering. We will dissect the equation V, which is equal to AT squared plus BT plus C. In this case, V represents the velocity and T represents the time. A, B, and C are constant. By understanding the dimension of this constant, we gain insight into the underlying physical relationship and uncover the hidden patterns within the equation. Feel free to join us as we unveil the mysteries behind the dimension of constant and embark on a journey of mathematical discovery. Let's assume we're given this kind of problem that has to do with analyzing a physical equation. This is the equation we're given, V equal to AT squared plus BT plus C. How can we solve this problem? In this case, to find the dimension, the problem says the velocity of a particle varies with time, which is denoted with small letter t, according to the relation V, AT squared plus BT, and we are asked to find the constant. To find the dimension of the constant A, B, and C in the given equation, we are simply going to use the dimensional analysis. When we set velocity, we know the velocity, this is simply distance all over time. And we know that distance is measured in length and time is being denoted with capital letter T. So the dimension for velocity is simply going to be LT minus 1. Time, in this case, we can say the velocity has a dimension of LT minus 1, which is length per time. Time has that is the small letter t is given to be our time in this case. Okay, let's go ahead and solve our problem. In this case, we are given V, which is equal to AT, BT, and C. Let's separate this into three parts for it to be easier for us. We are simply going to say AT squared plus BT plus, which is the last one, we have C. In this case, we can say dimension of T squared, which is in the one we have in AT, we can say dimension of T squared. What happens to the dimension of T squared? Dimension of T squared are simply going to be capital letter T squared. In this case, for it to match the dimension of velocity, and we said the dimension for velocity, let's just give it V, is what? LT minus 1. For this to match the dimension of velocity, it must be L divided by T to the power of 3. Because initially, velocity is given to be L divided by T, and when you take the time upward here, it's simply going to be LT minus 3. In the case of AT, our T is already in square. If velocity here, L divided by T, let's say plus 1 divided by T to the power of 2. This is simply going to be L divided by T to the power of 3. That is why I conclude and state, to match the dimension of velocity L to the power of minus 1, A must have the dimension of L divided by T to the power of 3. And this is it for AT squared. What about BT? In the case of BT, the dimension for time also, the dimension for time is also T, capital letter T. To match the dimension of velocity, and we said velocity, here is given LT minus 1 also. In this case, if you set our velocity is L divided by T, and when you tease that, it's simply going to be LT minus 1. Let's take the first one. What if we set velocity, which is simply going to be LT L divided by T. Let's say plus. Our BT, we have only one T there. We can simply say plus 1 divided by T. At the denominator here, or let's multiply. L multiplied by 1 is simply going to be L divided by T. This is simply going to be T squared. We can conclude that to match the dimension of velocity, LT here in this case must be equal to L divided by T to the power of 2. What about the last one? In this case, C is just a constant. It must have the dimension for the velocity. Because if we set dimension for velocity is what? L divided by T multiplied by the constant less denoted to be 1. Velocity is simply going to be LT minus 1 is going to be multiplied by 1. Therefore, this is simply going to be LT minus 1, which is the same as the dimension is the same as for the velocity. At this point, we can finally conclude and state the dimension for A is simply L divided by T to the power of 3. Dimension for B, which in this case, this is what? Length per time cube. And here we're going to have length per time square. And the last one, which is C, is simply going to be length multiplied by time to the power of -1, which is what? LT minus 1. So, and this is it for this problem. Thank you for it.